Okay, now we're doing the review for 6.3. So, first question is solve 2 sine theta plus 1 equals 0 on the interval. 0 is less than or equal to theta, which is less than 2 pi. So let's isolate 2 sine theta. To do that, we'll subtract 1 from both sides. And now let's isolate sine theta. So to do that, we'll divide both sides by 2, and we get negative 1/2. So if we were to, sine of what angle equals negative 1/2, and that's got to be some multiple of pi over 6. And sine will be negative in the third and fourth quadrant. So this is going to be, this is 6 pi over 6, 7 pi over 6. Theta equals 7 pi over 6. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6 takes us right there. Well, these are the only two solutions on that interval, and there they are. So number 2, 4 secant theta plus 6 equals negative 2, and the interval we're working on is 0 is less than or equal to theta, which is less than 2 pi. Now, 4 secant theta, adding 6 or subtracting 6 from both sides, we get negative 8. Now, secant theta, dividing both sides by 4, negative 8 divided by 4 is negative 2. So now I'll replace secant theta with its identity 1 over cosine of theta equals negative 2. And now we'll work right over here. So therefore, if we multiply both sides by cosine of theta over negative 2, we wind up with cosine of theta equals negative 1/2. Little algebra there. And so on the unit circle, it's got to be some multiple of pi over 3, because the cosine of pi over 3 is 1/2, but we've got to be negative. So this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Both of those cosine values are negative 5 pi over 3 and 0. And 6 pi over 3, which is 2 pi. So then theta must equal 2 pi over 3 and 4 pi over 3. Good. So for number 3, we've got the cosine of 2 theta equals negative 1/2. And so what angles, cosine of what angles equal negative 1/2? Well, then 2 theta must equal, let's see, pi over 2 pi over 3, 4 pi over 3, and here's what they look like. Cosine 2 pi over 3, 3 pi over 3, 4 pi over 3. Cosine's negative for both of these in the second and third quadrants. Then now And let's get a couple more. So if we add 2 pi, if we go 2 pi radians around, well, 2 pi is the same as 6 pi over 3, so adding 6 pi over 3 to 2 pi over 3, that gives us 8 pi over 3, and adding 6 pi over 3 to 4 pi over 3, that gives us 10 pi over 3. And now let's isolate theta. So we'll we'll multiply every term by 1/2. We'll multiply by both sides by the reciprocal of 2, which is 1/2, and we get theta. And here we get pi over 3. And then we get 2 pi over 3. 4 divided by 2 is 2. And 4 pi over 3. 8 divided by 2 is 4. And 5 pi over 3. 10 divided by 2 is 5. If you notice what we're doing here, now we're at pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11, and so on. So there's 6 solutions. Now let's come up with a general solution. So theta equals pi over 3 plus, and if we add pi to pi over 3, we'll land at 4 pi over 3. So I'm just going to write k pi. And the same holds true for starting at 2 pi over 3. If we add pi to that, we'll wind up at 5 pi over 3 plus k pi, where k is an integer. And notice, we'll just keep bouncing from here to here, here to here, or here to here, here to here. And in each case, for any of those angles, and there's an infinite number of those angles, when we evaluate cosine of 2 times that angle, we will always get a yield of -1/2. So we've got it. We've got 6 solutions and the general solutions.